Okay, so what's up guys, it's Kabir aka Mystic Dragon EX here, and today we'll be playing with Gauss Rifle. We will understand the physics behind Gauss Rifle, its strength, working and a lot more. So stay tuned to the end, till the end and because we'll be doing some awesome stuff today. So now I will tell you what a Gauss Rifle is apparently. Okay, a Gauss Rifle is also known as a Railgun. Okay, in some cases also known as Coilgun, because not usual because in very few cases magnets are used in the Gauss Rifle, whereas in the practical purposes most people uses electromagnets, and you all guys must be knowing electromagnets because it's nothing but a solenoid which has some coils of metal wire wrapped around it, and when we pass electricity through it, it generates magnetic field. So yeah, it's basically the same thing, but yeah, we have magnets here instead of electromagnets, and this is just for demonstration purposes. I'll be telling you all the levels of it so that you guys get the idea of how does this work on different levels. Okay, what happens when we increase the number of magnets and everything. So yeah, we will tell you this today. So yeah, here we have levels like 1, 2, 3, 4. I'm just naming it at levels. You can name magnet 1, magnet 2 and so on. Okay, so at this level you can see that there are some balls, metal balls attached to the magnets. Okay, normal iron balls. Now what these balls do is this only. Like if I take this metal ball, and if I just release this ball, it would get attracted towards this magnet. Okay, like this. Then what would happen is this ball would shoot away. Okay, because this ball has some kinetic energy. Okay, why does it have some kinetic energy? Of course, because we also push it, and this magnet also attracts it with a force. Okay, so now obviously if a force acts on an object, it would produce an acceleration, provided that the object has mass. Obviously if it doesn't have mass, then you know it is not existent. So yeah, so it would attract it, and then what would happen, this other ball would get shoot off. Okay, would shoot away and hit this boundary which I've set here. Okay, so let me demonstrate it for you. So you just saw here, as soon as I left this ball, it got attracted. Okay, all the ball's momentum and kinetic energy transferred through this magnet, through this one ball. And I need to tell you that this ball which is primarily attracted to the magnet, they didn't shoot away, because see, obviously distance also matters here, as this ball is at negligible distance. Okay, though there is some distance like 0.1 micrometer or something, but it is just attracted here, so it is also hard to remove it away. So this the kinetic energy of this ball won't have any effect on it, though this kinetic energy of this ball would transfer to this ball and would reach the other end, which is this ball. Now you can see I can easily remove it because it is at much greater distance, or comparatively greater distance than the ball situated just before it. So yeah, because it has more distance, therefore force would be inversely proportional to the radius of the distance from Newton's law of motion. And then you can see easily it would just go away, because all the kinetic energy of this ball is transferring over to this ball, and thus just shoots off away like this. And then yeah, I put some this board behind so that it doesn't fly off. Okay, so let me tell you, this set I have got from Gauss Rifle set. Okay, DIY science kit from Be Creative. Okay, I would provide a link for this in the description, so do check out the description. And first of all, I need to tell you, I have checked the statistics, and I have noticed that literally everyone who watches my videos is not subscribed to my channel. Only 2% of the total viewers are subscribed to my channel. So please first of all subscribe. We are already at 180 subscribers. We would reach higher. Okay, we want to reach higher, so please subscribe. So yeah, I just want to tell you this. Okay, so yeah, this was the first level, as I told you. Okay, now you go to the second level. Now here it will get a little bit trickier. Okay, so it is actually really easy. Now what would happen if this ball, now there are two magnets, this ball would get attracted to the first magnet, it would collide with this one. The energy of this ball would transfer through this magnet, through this ball, to this ball, because it's greater distance, so it would get flung away, and then this would go. But now watch out, there's another magnet, so already this ball has some kinetic energy due to this ball, first ball. Therefore this ball, with having some initial kinetic energy, would also get accelerated towards this magnet due to it exerting a force on this ball. So thus again it just collides, and all of that, this momentum as well as this momentum energy, would transfer to this magnet and this ball, and would reach this ball, and it would shoot off with much greater speed than the previous case that we discussed when we just threw one ball at the first level. So let me demonstrate it for you. Though there are 4 levels, this level I have attached it on purpose, okay, just to make things a little bit interesting. So yeah, let me demonstrate it for you. Oh sorry, I guess I didn't do it correctly. Yeah, you can see here. So yeah, you also need to put it at a little bit greater distance, because if you don't put it, then it will just attract, as I just showed you. So yeah, you need to put it some distance so that it also has some initial momentum also to get it going, because these are really strong magnets. These are actually neodymium magnets which I purchased from online. Okay, yeah, they have a lot more strength than as compared to the ferric magnets, that are the black magnets that you buy from the shops, apparently the fridge magnets kind of thing. So yeah, these are actually really strong magnets. Okay, that's why they're tied up, and I guess this is going away. I need to tie it up here. Yeah, perfect. This is the only drawback of this set, that it just magnets also move away from this because of the reason that I showed you. Okay, let's get back to our thing. So now we did 2 levels, and now we'll go to 3rd level. Now we have this ball also over here. Same case, when this ball is going to attract to this magnet, energy would transfer, reach this ball would get shoot up, attracted by this magnet. Again energy would get transferred to this ball, this would again shoot up, and again energy would be transferred, same case, to this ball, and this ball would now shoot at very high speed because of the energy being added on all the previous cases. So let's shoot away, and let me demonstrate it for you. So yeah, look at this carefully. You can even slow this down because of the YouTube feature. You can easily do that, and you can check it for yourself. So yeah, you saw that this ball went with a very high speed. Oh my goodness, apparently this whole set fell down. Okay, so yeah, let me reset this. Okay, so you saw that how high this speed is, how high this speed really is. Though this ball doesn't have much momentum because its mass is very less, though its velocity is really high. But now we will go to the 4th level, which is the final level that I have in this set. Now you can see here I've got a really tiny ball, but this would also help in doing the same process as I told you earlier. So yeah, this is the 4th level. Now you can see I just got this ball. I just accidentally left this ball, and they all went away. It just instantly just goes away. You won't even see in a blink of an eye, like in a jiffy, just goes. So yeah, let me demonstrate for you. In the same case, energy transfer will take place, goes on till all these levels until it reaches this ball, and this ball will get flung away with the same principle as I told you. So yeah, let me demonstrate for you. Yeah, this was the energy. So you saw how much force does these balls and the magnets back here. Now this is called Gauss Rifle. If you replace the magnets with a, let's say, electromagnet, then this would produce much large magnetic fields and much larger acceleration due to the strong magnetic fields, obviously. So yeah, this ball would let's say assume that these magnets were electromagnets. Okay, so if you release the ball from the very end here, the ball will get attracted, and because it's an electromagnet, it will produce a very strong magnetic field. So this ball would literally go away with very high speed. Then again the same process would get repeated, where it's repeatedly attracted and flung away until the very last ball is flung away, and it's just so fast that it's almost like a gun, like a real gun. it is actually used as a railgun. That's why it's named as a coilgun and a railgun as well. And because it's just a demonstration set, so I can show you what the strength of this is. I've got myself a die. Okay, I've already set up this apparatus, and now I will tell you what the strength of this is. Though I know it's not that much because it's just a demonstration set, but yeah, you can see this. This die just got flung away, and this ball also returned due to the third law of motion. Every reaction is equal and opposite reaction. It pushed this die, and it bounced back here to get again attracted by this magnet because there's a field. So yeah, this flung away, and yeah, you know, this actually if you just measure its speed, it's a lot, but it doesn't have that much momentum, so that's why it didn't go away with much high speed, very high speed. So yeah, if I even put my hand over here and just shoot it, I would feel a very very little force because of the same reason I told you. So yeah, this is the Gauss rifle apparently. Now there's no limits. You can add a lot of levels. You can do 1 level, 2 level, 3 level, or infinite levels if you have infinite magnets. That's not possible, but yeah, this is the Gauss rifle. I've got some extra material also here. Okay, these balls, and obviously this set. This is a really good set. Okay, you will get three magnets and these big balls. These small balls are some other balls which I took from my fidget spinner, you know, when there was a craze and when the fidget spinners already obviously had those metal balls in their what we say, hand kind of thing, apparatus. So yeah, I just melted it and took these balls out. I thought they would be helpful for me. So yeah, I'm getting off topic. Let me return to my topic. So yeah, let me get this aside and let me actually tell you what is the principle behind this. Okay, so yeah, you have a magnet like this. Okay, you have here 2 balls like this, and now you have 1 ball, metal ball. Okay, now let's say it's launched with a velocity, let's say it's v. I would tell you both cases when its velocity is 0 as well, initial velocity 0. So now this magnet would produce magnetic fields. Okay, normal magnetic fields. And you know, the magnetic field produced by a magnet is not uniform because it's a magnet, and electromagnet produces uniform magnetic field, but this magnet doesn't do because it's artificially made. So yeah, we cannot write a general equation for it, but let me exclude that as well. Right now I would just demonstrate this. So yeah, because of the magnetic field, it would experience a force. Okay, and because of that force, this ball will be attracted in an acceleration a. Let us assume that it is a constant magnetic field, and therefore the acceleration is also constant. So it would move on till here when it reaches this ball, to this part. When it collides of its momentum, let's say it's m. This ball has mass m, so its momentum mv, and its kinetic energy half mv squared will all get transferred to this ball. Now this distance is really small, and from Newton's law of motion, we know force is inversely proportional to radius squared. But this is, I guess, if you don't know Newton's law of motion, is basically for gravity, but you can apply to general cases as well. Okay, you can derive it like this, but instead of taking radius, you can take the distance as well. So lesser the distance, more will be the force experienced by it. So also, you know, because it's just here, it would experience a much larger force than this momentum and kinetic energy. So this ball won't get shot away, but this ball is at a greater distance. Okay, if this ball has a distance d, now this end, this end d, and this is very less distance. Let's say name it as d. Let's say we name it as x, and this distance is dx. Very little distance dx. Okay, so yeah, I can tell you, was a very little distance dx, and this is a distance x. It would experience a much less force than the force experienced by this ball. Therefore, this ball will get shot away, and that's the principle behind the Gauss Rifle. And when this ball is getting shot away, all this momentum, that's half mv square, mv also, and half mv square kinetic energy momentum, all get transferred to this ball through all these levels, magnet and ball. So yeah, this would also get get shot away by the same half mv square and momentum mv, excluding the frictional force and other resistive forces. So this is the basic working of it. If you want, you can add more levels. This would be the same thing. Okay, you just put two balls right here. Same case, if you take v, let's say here we take v is equal to 0, then this would normally get attracted here, shoot away, momentum transfers to this ball, it transfers to this ball gets shot away, reaches here, collides with this, all its momentum get transferred to over here, and then this ball, I guess it was off centered a little bit, then this ball gets shot away with the momentum of this ball and this ball combined. So yeah, much larger velocity, much larger momentum, much larger speed. So yeah, this is the basic functioning of the Gauss Rifle. I know I've said it too much, but it's just like this. Now if there was a, let's say, what we call it, electromagnet, then obviously the magnetic field would be much stronger and the velocity produced would also be much stronger, acceleration also would be much stronger. Therefore this ball would also get shot away with much higher speed. This is the basic working of the Gauss Rifle. So now you can try different experiments with it, as of putting this rifle at an angle with the ground, okay, to test whether how much high does the ball go, and you can even do it like vertically. Okay, though this would work, okay, but most of the times the ball gets these balls just get flung away here and there, because obviously, yeah, look at this just like this. So it's not practical, but if you have this area covered, then this might be practical for you. Otherwise you can try it on one level as well. It's just the same thing. You can experiment with different kind of materials. I took the dye. You could have taken like this cardboard also and some other materials, just to test the strength of the Gauss Rifle. Now practically this rifle is really used in the railguns that I talked about earlier, okay, and in the coilguns as well. So this is kind of like a modernized weapon, okay, though this is not a weapon. Originally it could be transformed into a weapon, but this is not a weapon. So yeah, it's just based on the perspective and how you make it. This is just a creative educational toy, as it is mentioned here, but you can modify it to just make it a little bit cool. So yeah, I guess I talked too much of this Gauss Rifle and experiments because it's just so fun. I know right now it might seem boring, but when you try this at home yourself, when you make this kit, okay, I would be posting this link in the description below, so do check it out if you want to buy it. If you do want to make it, then you can try different varieties of it. You can put it at an angle and everything, and this would make it just a lot cooler. I just love this Gauss Rifle kit. It was just so fun making it as well as trying it. So yeah, if you like this video, be sure to give a thumbs up and do comment what you want to do, what you want me to do in the future, like what science experiments do you want me to do and everything. And yeah, I would respond to them. And yeah, obviously you could post any suggestions in the comment section. I would try all of them. I would basically like what you all suggest and would try all of them. So please do suggest what you want me to do. And yeah, take care and be safe from the coronavirus outbreak that has occurred in this world. Okay, please be safe, stay at your homes, and keep watching my videos to get a lot of science updates and facts. And do subscribe to my channel for more quality content. Stay tuned, Mystifiers, and peace out.